Hello everyone, I'm Kaixing Zhao from University of Toulouse, France. Now I will present our paper entitled Tactile Fixations, a behavioral marker on how people with visual impairments explore wrist-like graphics. Wrist-like graphics, as shown in the figure on the left, are commonly used in special education for people with visual impairments. These graphics are often printed on square touch paper and allow people with visual impairments to explore them with their finger touch. However, as illustrated in the figure on the right, the design process of wrist-like graphics highly relies on the experience of the tactile document maker, and the efficiency of the tactile transcription and adaptation depends on many factors, especially the targeted end user. Therefore, there is need to better understand how people with visual impairments explore the different types of wrist-like graphics. The knowledge may help to improve the graphics design. To introduce the concept of tactile fixations, we draw inspiration from eye fixations. When searching for specific visual information, human eyes are either in movement or stationary. As shown in the figure on the left, the points represent eye fixations. In the domain of new visual accessibility research, we made the hypothesis that the eye fixation paradigm can apply to the tactile exploration of wrist-like graphics. We define a tactile fixation as a finger behavior that occurs when the finger is stationary within a specific spatial and temporal window. There are several differences between eye fixation and tactile fixations. For example, the hands can move along an outline and do not always jump from one element to another one. In addition, the two hands are more independent than the two eyes and allow complex two-handed strategies. In our paper, we proposed several research questions. How to detect tactile fixations? Do tactile fixations vary according to the hand, graphic type, and the exploration task? And can we relate tactile fixation to exploration patterns? Based on the idea of eye fixations and the definition of tactile fixations, we designed a computer vision-based algorithm to identify the tactile fixations from the videos of tactile exploration of wrist-like graphics. As shown on the right, the yellow point and the orange square represent respectively tactile fixations on two hands. By conducting a behavioral study involving 10 people with visual impairments, we found that there were always more tactile fixations on the left hand. However, tactile fixations on the right hand were generally longer. We also found significant differences between different types of graphics, and shown in this figure, there were more and longer tactile fixations on mathematical graphs, geographic maps, and neighborhood building maps. Finally, we investigated the role of tactile fixations during the exploration of wrist-like graphics. We notified 3 different exploration patterns from 296 exploration videos. We divided them as anchor point, switching fingers, and chaining hands. We give an example for each of these exploration patterns. First, the anchor point. The right hand stays as the anchor while the left performs several tactile fixations. Now it's an example of switching fingers. The two hands are used alternatively as an anchor in this pattern. Finally, the chaining hands pattern. In this pattern, one hand always follows the tactile fixation of the other hand. In summary, the results from analyzing a large data set of finger exploration demonstrated that such fixations not only exist but also can help to illustrate the different behaviors observed during the exploration of tactile graphics. Special education teachers, tactile document makers, and interaction designers can therefore leverage tactile fixations to propose exploration recommendations for people with visual impairments or guidelines for professionals. Thank you for your attention, and for more details, please refer our paper.